And switching to the host. Okay, it's live streaming now on the Vivid Worldwide website, on YouTube, and also we're recording this for the Espresso Talk. So this is a podcast for the Vivid community. And today we're joined by a very good friend of mine, Huw Price, who is the test guru. And give us a bit of background about yourself, Huw.
Yeah, I probably class myself as a kind of software inventor, trying to create software solutions not out of what people have done in the past, but trying to predict what people should really be doing in the future. I guess that's kind of what I've been doing for about 20 odd years. And we've sort of moved into the test data space and, and to the model-based testing space. And I think we've kind of shaken up the testing world. It's quite funny how many companies seem to mirror a lot of the stuff that we came up with. We came out with a phrase test data automation about 2 months ago. And magically, a lot of other companies now seem to be using test data automation as a phrase. So I guess that's a good thing, Anyway, there we are.
Yeah, definitely. I think part of it is you are a trendsetter, and I've known you probably too long now, but from a from a kind of I'm wearing the Agile Designer T-shirt, and especially I guess Grid Tools. You started that company, and it was pretty much at the forefront of model-based testing, right? And the stuff
actually, there's a funny story. That was actually invented on a headland in Wales on a rainy day when I'd been trying to persuade people to get into a thing called cause and effect modeling. And my favorite customer said, "Look, Huw, he was actually a Swiss guy. He said, look, we love this. We love all the benefits of it, but there's no one ever going to be able to use this. It's too hard." And then I said, well, actually, we've got to drag the mountain to Mohammed, and we've got to make it easier to use. So that's kind of where we took, which was basically business process modeling into model-based testing, and overlaying business rules on top of models, really, because that's the tricky bit in terms of finding the optimal set of paths to test complex systems, really. So that was kind of where that little baby came from. A light bulb moment.
A light bulb, which changed the industry because obviously Grid Tools were hugely successful. They sold on to CA Technologies, which then became Broadcom, and literally it set the scene for model-based testing. And kind of a lot of the foundation work what Dick Bender had kind of put together about cause and effect modeling, and exactly. Then really this became available to testers, right? And it kind of changed the way the face of how we test today, really. And I know when we were working out in Santa Clara, part of the challenge there was kind of this model-based data kind of aspect, in the sense of your background, like you said, is as a kind of a data inventor, has always been TDM. This is your third test data management company, and you've pretty much defined what that means in the industry. And so, how important is test data?
Yeah, I suppose we're kind of focusing on, DevOps, CI, CD. The reality is it's speed and quality together. I guess that's what we've been talking about. Pretty much every whiteboard we ever get close to, we're always talking about how you actually make that faster and make it more reactive, in terms of knowing the dependencies up and down the stream. And the reality is that the test data just can't keep up with the world that we are in now. And that's it. And automation. There's cool automation tools out there, but they're so fragile. And it's you basically it'll work for about 2 to 3 sprints, and then all of a sudden it'll break because we've changed our master account record, and that's kind of hard coded into a bunch of automation scripts. So if you're thinking about more automation and, with sort of Docker and, as you know, all the vertical and horizontal and shift right and shift left, you've got all this wonderful information and ability to scale. But the crucial point sitting in the middle of this is the test data. If that doesn't support all of those wonderful pieces of technology, it becomes incredibly fragile, and suddenly you're in a big panic, and what you tend to do is just turn off tests and then come back to it, and you're basically back in the same world you used to work before, which is, hero culture to try and fix something which really isn't kind of where we need to be now. You need to be able to basically spin up releases, push them through, have elastic, I'm not sure if this is the right term, you probably, kind of elastic expansion of tests based on the feature and the risk of what the feature is being pushed into production. Is it a simple report? Is it simple, adding a button? Who cares? But if it's actually something in the plumbing, you need to think of an elastic expansion of the different type of tests, which means you would need elastic expansion of the automated code, but also you also need elastic expansion of the data to support that. So I think that is really kind of, it's always been a missing piece of the puzzle, and we've tried to really focus hard on supporting that DevOps journey this time in terms of building new technology, using all the cool stuff that's out there. And there's so much free stuff out there. It's amazing. The Git is just an absolute treasure trove of wonderful things, in being able to just apply those and bring them out to the industry as just useful things that people can apply to solving this incredibly complicated problem.
So I think that's a great leeway to kind of where I wanted to pick your brain, really. So I'm actually, I've spent the last week, I'm on week I'm 35 being isolated. So 35 days I've been in isolation, and I'm working with the guys at MIT. So, I know you've done some sentiment analysis using some of the libraries that in Slack, to understand the, that side of things. So I'm working with Yasemin, who's the owner of an MIT project called COVID Safe Paths. So I literally spent the last couple of weeks running their QA capability and getting this product to market, which is literally going to go launch this week. And it's
well done.
around.
Well done, and thank you, by the way.
Well, we're doing everything we can. So part of it is this is contract tracing, which is a big thing. Which I know I spoke to the NHS yesterday. The NHS are doing the NHS X contract tracing mobile app, which will maybe a little bit later than the MIT one. But the MIT guys have got launching it out there, and they're using healthcare authorities, so the ones in the US that I know you've worked with in the past, to look at two main things part of contract testing, just to get tracing, just in case you're not familiar with this technology. What this is so Apple and Google have been working on Bluetooth APIs with the information that you get on GPS to look at if you potentially cross paths with somebody who's got the COVID-19 strand. So this, I've just finished writing a book on cognitive engineering, which is going to publish this the end of the month, which I've now included that, and also included your model-based testing approach and your test data automation capability, because you've been at the forefront of this. And so all the stuff that we've been doing with that, working closely with the MIT guys, has been around being able to synthetically generate GPX historical data, and so this brings us back to kind of our last time we worked on a project for the Copenhagen Smart City Data Exchange, and that was a mobile app which was helping people become carbon neutral by 2020, which is now. And what that did was that had people walking around. It'd recommend the most carbon neutral way to go, and so that could be bus, multimodal transportation, so things like tubes, which you're getting on a tube and then appearing somewhere else on the GPX map. Now they want to use that same technology to be able to understand whether or not me walking to me going shopping to get food supplies, or frontline NHS staff, have they crossed paths with somebody who's been infected. So they're using Google location data. So anyone who's got an Android phone, I'll grab an Android phone, has Google location data set by default. So that's 650 GPS locations per day, which is captured on everybody's phone who's out there now listening to this. And you can upload that data, and then you've got the paths of every 5 minutes of where you've been. So you can take that data, and my uncle's just been admitted to is now as caught COVID-19 and is in a hospital intensive care. And what he would be doing would be uploading the MIT Safe Paths application, accessing that data where he's been, and then that would then go to the medical authorities would populate that data back into a big data exchange, and then I would get this app which I've got in front of me, which is the COVID-19 app, which would tell me from the green locations if I've intercepted somebody who's got that that who's caught the COVID-19. Now we did this, or you did this for the Copenhagen area, and this isn't possible without your technology. Partly what we did with the Copenhagen project is we got some deltas, so we got a whole stack of GPS data which we captured from students in Copenhagen who helped us out, who walked around with a GPS logger enabled on their phone. And then you took that data, which is also that data is now being used by MIT. You took that data of them walking around and tracking them, and you then synthetically generated 5 billion historical transactions to give us a data set that we could actually test against. So a large set of data, a bit of a data lake if we go there, but with the idea of being able to understand, give us some data, some information that we can test against to avoid false positives. Because an easy scenario there is, I've got a car driving in the back of me, but a GPS location driving a car, if they pass, say, for instance, a supermarket where I was buying my critical food, and it wouldn't.
Yeah,
and it gave me a red.
There's things like they're the other side of a wall, things like that. Bluetooth can get through a wall. So I guess, there's. I mean, it's a brilliant idea. I suppose the privacy stuff just needs to be kept an eye on there. But so I mean, it's a fascinating space. I mean, we've actually been doing a bunch of work in sort of data point modeling and also search engines. Actually, search engine testing is actually quite an interesting space, because it's not a lot of the model-based testing is it's binary. So come back to cause and effect modeling. It's switches saying yes, we have a contact. No, we don't have a contact. Whereas actually, if you think about searches, it's almost like it's an applicability of this search. It's how close am I? It's a closeness, and it's actually not a physical. It's between 0 and 1. I'm looking for something specific, but I only give a certain amount of information. Therefore, I only have a 0.2% match. Therefore, I then refine it and I go through it. So it's more about this idea of kind of an iterative approach. Now, the problem that you have with 5 billion rows of data or 5 million rows of data is classic big data testing problems, is that if you don't know what's in there, you can't validate that you've actually got the right result for the right reasons, which comes back to good old cause and effect modeling, actually. You need to know that I got this. So you have a hypothesis, and I want to prove that this hypothesis works, that I found this contact. And to do that, I need to be able to test almost every single decision and every single rule that's coming through that. So I have a rule that I was in the same room for 5 minutes, and we know it's a room, and I was in contact with that person. Bingo. That's a basic rule. But then it becomes more sophisticated as you have movement involved, and you have all of these different things overlaid on top of each other. So it's creating data which is fuzzy, and then knowing it's fuzzy, and then being able to say that we're getting we expect this to be roughly about 0.6, and we're getting about 0.6. So the match then is that becomes a 1. So, and then it's the fuzziness that as you get further away. So it's creating much more sort of almost randomness in the data to be able to make sure that you're checking these as you want this to become more and more sophisticated, rather than this kind of very, very binary approach. I met them and I moved off, which is probably fine, to be honest, for about 80-90% of this. But as this becomes much more sophisticated, and especially when you're getting chaining of data across to multiple contacts where it suddenly explodes, it's like fireworks going off, isn't it? And some fireworks just don't go off and some do. So you've got to be able to create this kind of pattern of, we actually had a family barbecue. That's 20 people that have suddenly gone out and met with another 20, have met out with another 20. And it's this R factor, isn't it? You want to make sure that R factor is less than 1. So being able to simulate those fireworks is actually quite a sophisticated way of being able to generate the data. And it's almost a little bit like creating snowflakes, which is kind of one of the concepts I use. You need to make sure that every snowflake is different, and you would know the expected results for each particular snowflake. So I think that the interesting bit, maybe we can talk about this kind of separately for this project, is if you can give us the definition of what those snowflakes to be, and then we can play around with the variability on them, and then even the ordering of the way things happen as well. If you think about a search term, black shoes, and then you say black dress shoes, dress black shoes, all of the ways that you approach those things are actually, what's that, that's 2, 3, 6 different potential combinations of that with 3, but then if you have 2, the numbers start to grow dramatically. So I think this is where AI actually makes sense, and it's sort of almost testing the AI engine, but to do that you actually need a ton more data. But you really need to understand the data that you're creating. You can't just rely on, 100 students wandering around and then trying to work out what they did and then work out if that fits the test that you're doing. So you need to sort of almost think of things the other way around. Let's create the data. So you're actually modeling the data based on the algorithm that's trying to test it. And that's really, really interesting. So if you look at something, there's a thing called financial reporting, which is called XBRL modeling, which is massive in the finance world, and all the banks have to report up. It's incredibly complicated, and it's classic. How do you test that the financial reporting is correct without creating loads of these XBRL documents? So you have to kind of start at the end and then work your way back. So it's actually kind of some of the stuff we're working on at the moment. It's really interesting stuff, and it actually has. If we come away from COVID as well, it's actually massive. I mean, if you think about how businesses survive nowadays on the online world, is you need to be in the right category. You need to be in the right category on Amazon, and Amazon's changing its algorithm all the time, and you need to make sure that you can detect that, and that you can also have data sets, because Amazon's trying to outguess you and you're trying to outguess it. So you need to be able to react and say, well, we know that we categorize our things correctly, but we need to then predict what's going to happen by being able to create different sets of data to see what's going to happen when those get put into something like a search engine, because then you drop off the market and suddenly you're out of business. So I think there's lots of applicability beyond COVID as well in terms of this more sophisticated way of being able to synthetically create data. Here's my egg, here's my chicken, but I'm starting with a chicken kind of thing.
Yeah, I know there's another client that we worked on which does exactly that. They use computer vision to look at products from major manufacturers, and then they enrich that data. So we talk a lot about ETL, right? The enhance, transform, and load side of things. But they look at the image, they look at the tags, they use a graph database to actually understand whether or not it's a pink shirt with a pattern on, and then they understand the best match for Google Marketplace versus Amazon versus eBay. The way that Instagram and Facebook are both going at this at the moment is, I'm wearing this shirt, the picture goes onto a social media, you can click on this shirt and order it from somewhere that, based on, it will search through the image catalog and say, we've got a shirt that's similar. It's obviously, this is a unique shirt, but the idea is everything you see you can buy, and you can then buy that through. So the idea with Instagram is that actually you would never go to the end merchant. You were literally in that B2B kind of landscape, just disappears. The customer can order it through their Facebook or Instagram, purchase it, get it delivered, and it doesn't matter who it is who's buying it, which opens this disruptions around retail, right? But I'm going to go back slightly to COVID for a second, just based on what we talked about with the model-based testing. One of the big challenges we had when we were out in Santa Clara with one of those people that I mentioned before, who do a well-known mobile provider of hardware. Part of what they needed to know is each time someone goes onto, say for instance, an app store and buys something, each one of those is maybe an ERP CRM transaction, which is an iDoc written somewhere, and there's millions of transactions going through as people are buying stuff or downloading the COVID Safe Hands app. Each transaction has to be dealt with, and then what they're interested in is well, what people are buying, what is, the behaviors, what is the top app which people are doing. That, back to your kind of searching side of things, is, it's incredibly complex, but without modeling it. And I remember this time when we were speaking on the stage at Star East around Pokemon was the example we gave, and someone had set the challenge that there's no way you can test Pokemon because it's just infinite complexity. But within a couple of days, you guys had already modeled it out. I'm working with Iran at Perfecto to actually.
It was an intern that did that one. We said, "Oh, can you model Pokemon?" And it was, a classic 18-year-old who'd been playing Pokemon for about 2 years, and it took him about a day to do it. It was actually kind of really cool. Anyway, carry on.
But yeah, it was infinite possibilities because it's taken GPX data in, which is where your location is. You've got swipe gestures to catch the Pokemon. Different types of Pokemon, different types of GPS location, augmented reality, so AR, which we're seeing in the background at the moment. Huge amount of complexity, but the foundations were exactly the same as what we're talking about now. Is the fact that, what speed was I walking 3 miles an hour versus bike at 12 versus car at 70 versus bus at 40 versus, all these different types of multimodal transportation all have a unique path, and it's data visualization which is absolutely essential. And so I've been working literally yesterday with Yasmin, the owner of the app, and Todd DiCaprio, who's in the background in a second, from Splunk for Good. So Splunk obviously are using data visualizations, huge amount of data, and visualizing it. They're visualizing the COVID-19 pandemic at the moment. We're trying to use it because we're looking at testing in production, right? We need to understand this shift right perspective of what are people doing, what are those frontline staff doing. And it's really interesting because after reading your latest material around that, all permutations aren't actually exercised in production. So a lot of companies will take production data and think that all possible scenarios are going to be included there.
What's the point of testing then? Why bother with a testing team? If that's the attitude, why bother? You just get rid of QA because you're just going to use production. The whole point of QA is to think of the unexpected and think of the differences and be able to push through and test the system for the stuff that doesn't exist. It's not so bad nowadays, but in sort of 5 years ago, people were just absolutely so hung up on production data, it was crazy. And also that it has to be the volumes of data are critical. Whereas actually 96% of the data is exactly the same. So, and there's so many war stories. Payment systems being backed out after 10 minutes because 99% of the payments went into a manual holding, and they tested it for 3 to 6 months before they went, So there's just so many stories in that space. So, this idea of being able to think, coming back to Pokemon, actually gaming's kind of interesting. If you look at the way games are tested, you pick up a water bottle on the ground and it burns your hand. Okay, but that's just, if you think about that water bottle, it's just an object. Now that object actually has its own kind of world of programming associated with it. What's happened is because that water bottle is surrounded by, it's been sitting on the ground near a firefight, it's got hot. Now that's completely, you can test whether that thing's get hot or not on its own. And all you're doing is testing that piece of the software works. Then you have another piece of the software which comes along and says, "Oh, I picked something up," and then is it hot? It's just a 0 or 1, and then you have to drop it. So if you think about the ways that we thought about sort of the Pokemon problem, actually, it's more about the ability to break problems down into small components, which comes back to Einstein's theory. The secret is to break things down to smaller problems, but the skill is only going so far. So you've got to take it down to something which is a component which can be tested in reality. And it doesn't take long. 2 times 5 times 6 times 9 times 15 times 14, and you're done. There's too many. So it's this ability to break things down into smaller components. And I suspect with the COVID example, it's this idea of just testing each component to make sure that it is successfully working. Because if you just have one of those being slightly wrong, and then you start chaining them on top of each other, then it explodes into the errors, then become much more drastic. And that's pretty much true of most government projects, actually, or large IT projects where they haven't really thought through the impact of the complexity of the interrelationship between components and modules. So I think with the COVID one is to break it down into the small enough module and make sure that is like good programmers will test a unit test something to death, and then they might put two things together and test that integration, and it becomes a module then, which is they're 100% certain that this actually does what it says on the tin, including the validation, which is the bit they always forget. So put that together, and I think with the COVID thing is to just test each rule and then you're testing the interrelationship of the rules on top of each other, and then you're testing the ordering of the rules to see that the ordering of the rules is actually behaving the way that you expected. If information is coming through in different sequences, does it get the same result, or should it be different? So without people thinking in terms of these logical components and testing them individually, independently, and all of this is data-based, then that's where modeling and data comes together, because then you're creating enough data to prove the hypothesis correctly, and then it proves it for the right reason.
Yeah, and so one of the other things I'm doing kind of is digital twins, right? Which I know is what we've been talking about for probably the last 6 years, which is shifting right. It's taking that data set and learnings from the right-hand side, so that's from your APMs, to understand what you're doing, and then validating, well, how is the model, and challenging the model. So like Paul Gerard would say, models by default are, not perfect, and you need to refine those models. But there is, like you said, there is this risk that if only 20% of all the possibilities are actually being exercised in there, then you're not going to potentially get all the enhanced transforms and loads. Partly what Iran put a demo together this morning, which we were looking through, which is one phone going along driving at a certain speed, another phone going along that same path but walking, another phone walking down, and it both hovering together in the same geo field. To then the test further down is that day then becomes a potential risk. Now this is the problem, it's trust, right? It's trust off the system that you're using. If it says to me that I'm potentially got it and I self-isolate for the next 14 days, this is going to change people's lives. If that then is found to be invalid because the algorithm wasn't correct or it wasn't trained enough.
Oh yeah, 100%. I think a better example actually on that space is that there's only going to be a certain number of people, in the local authorities that can actually go and track people down. And if you've got 25 people and 20 of them are actually going off and actually wasting their time trying to find people and say, look, we just noticed that we need to solve us. And, that's actually complete waste of their time. We have very, very limited resources. I think in Taiwan, they kind of mobilized 50,000 people to do this. I think in the UK, we're much more disorganized. We'll probably be lucky to mobilize maybe 1,000 or 2,000. So wasting their time when they're not finding people 100% of the time is basically means that we're not going to be able to track, test, and kill. And then it's just going to constantly come back. So you're at the cutting edge here, and it needs to be that algorithm. If it's 1% more efficient, that might mean 25 less visits by someone in a car going to visit someone and to take their temperature and do all these things, and when they don't have it. So I think it's incredibly practical what you're doing. But let's get it, if we can make it 1%, 2%, 3% more efficient, that actually boils down to getting that R number down below 1.
And it's saving lives. And partly what we've done before with, and I know your guys did you had some really smart guys who doing things like graph theory and stuff to understand what's the confidence we've got against this particular system. And I think this is the thing, when we talk about cognitive engineering, we talk about artificial intelligence, machine learning, which we're actually talking about, Neo4j and your graph DBs and TensorFlow for computer vision. We're talking about training underlying systems with an algorithm to detect shoes or detect types of shirts and colors and stuff like this. That 1-2% tolerance increase can also mean overtraining the algorithm. And part of where I think the challenge for all of these guys, and I think you guys are at the forefront when it comes to testing these kind of AI systems, and I'm working with the ISO committee at the moment on the new testing standard for AI, and part of it is it's crazy around, well, how do I synthetically generate all those permutations so that I've got a data set, because that system didn't exist. It needs to be able to create the data lake with information that you could train that doesn't have a cognitive bias, so it's not, going to go towards, being really good at recognizing pink shirts, but doesn't have a real spread. People have this idea that if I type in the word t-shirt into Google, that is the perfect set of training data. No, I need all types of shirts, all types of styles, and I also need to have the right amount of balance, because if I overtrain it one side and it increases, so maybe 80% is recognized by the system and 20% are misclarified. Those 20% need to be done by augmented intelligence, things like Mechanical Turk or whatever else, to get humans to look at it and go, yeah, that shirt's pink with a logo on it and tie-dye.
Well, you got cultural references there as well. I mean, every person is basically a bag of cultural references. I'm a boomer. You're a whatever the hell you are.
Millennium.
I'm a white male. I'm middle class. All of those things actually just any kind of training I do would be pretty much useless. My daughter would do completely different training to me. So I suppose that is one thing about the training systems. But coming back to sort of the more trying to be more systematic about it. I mean, I think at the moment what we'd probably be working on is trying to generate the data that you need with a degree of parameterization, and maybe using some of the cleverness that is out there and just plugging into some of these kind of fitness or giving us. It's almost like it comes back to almost statistic, isn't it? It's like a statistical, closeness. How close am I statistically to this? And I need to know that when I create that data. I'm creating something that's going to give me something on this point of the curve, and you need to be able to detect that. So, and that's fine with a simple curve. But when you go multivariate analysis, when you've got 7 or 8 different moving parts, that's actually really complicated. So it's almost like taking the statistical algorithms and turning them around the other way. And each one of those, but it needs to be discrete so you can test each one, as I said before. And I think that's the bit. Just chucking it into a data lake, it needs to have the reason I'm here is because of this. You can't merge it all together, because then they'll just blend on top of each other, and all of your algorithms will suddenly just fall apart, because suddenly you've just chucked in 3,000 other journeys down that road by someone else because they're testing something like that. But I mean, with computing power nowadays and Docker and all this ability to separate things, you might end up with 1 million data lakes, and each one with 48 rows in it. Do that first, and then start merging them together and see what the effects as they kind of disappear away. So I think maybe that's kind of the way to think about it. Or you have to change the system. I think one of the key things that people forget when they're building systems is how testable is it. If you can't test it, you shouldn't deliver it, and you need to be able to test it to prove that it did it for the right thing. So I'm a big fan of breadcrumbs. Whenever you put data in to a system, track why it got there, because then you can prove your assertion with your expected and actual results should match, but they should also include the breadcrumb. The reason this is here because of that, and I think without that in there, you can't test the system, because you haven't built testability into the system, and that's understanding why that data is there. And therefore, I found it for that reason, and not just I found some data.
Yeah, and I think I remember we were doing a session, and there was Dr. Emma Langdon, who does systems thinking, right? And I think that is those kind of principles, is understanding that. But you've just come up with a fantastic idea, which I'm going to pass on to the MIT guys, which is so we're working with Google at the moment on their APIs for mapping. And we've asked them for traffic information so we can see if for instance that route was a public transport, i.e. a train or a bus, which they have that kind of information around maps. But actually they've got also recently acquired the fitness Fitbit, right, which I know you're a big Fitbit guy as well. But using that data, we could use the Fitbit data to actually use as a great reference, because that is data that people have already donated. And we know some of the horror stories, like for instance the US government. People could see where the bases were because Fitbit were the guys were all running around in the secret base with the Fitbits and then publishing the data to Google, right? But you're exactly right, because one of the things that we do is each one of these health authorities is going to have a Docker container, and what happens is you publish your data to it, so it's just an API endpoint, and that data then is used on a data visualizer, which is Google Maps. So it shows you where you've been, and then you can, because privacy by design, we need to remove people's like their home or their workplace. Anything which is sensitive data, which I know is a big thing which you do around GDPR and PI data. But once they've geofence that information off and then push that information back from the local, they kind of interview them and go, what was you doing here? Was you in a car? Was you going to the shops? Once that data has been sanitized, it then gets pushed back into the centralized data big data exchange, right? But actually you've kind of hit the nail on the head. Is if you're able to use data from fitness trackers as a good example of reference points, but also the importance of how does those individual health authorities take that data and how they manage that, and how they manage the flow and the data privacy, because people need to make sure they can control their data. And I know you've done a lot around obfuscating data. How important is this to financial organizations, healthcare organizations, all the different industries and verticals that you work on?
Yeah, I mean, I'm a big fan of GDPR. I mean, I just think the way companies use our data is just kind of appalling, to be honest. But I suppose the area that we've really focused on is using production data in development systems, where suddenly all of those wonderful privacy controls aren't really there. So we do a lot of work with trying to obfuscate and mask data, but the reality is that actually it's not very hard to track someone down. If you know one piece of information about someone, the chances of it being obfuscated out of that data set is pretty rare. So I know a colleague went to see the doctor yesterday. I could probably track them down in the HR database within about 5 minutes, even if it's been masked to hell. So there's those types of things that people need to consider. And the reality is that I think it's much better to look at production data sets and understand the characteristics of it, which is actually, there are loads and loads of data scientists out there. Accenture have hundreds of people doing business intelligence. Understand what the production data looks like, and then synthesize a better version of it. That's it. It's actually a lot easier to generate data than it is to mask it. It's actually so much easier, especially with privacy controls, because you can't actually get at the production data to understand it, to mask it. Whereas just scan it, understand the characteristics of it, by just running simple BI reports. You don't care about the names, you just care about this core information. Create a set of views on top of some data. Once you have that, then just synthesize the hell out of it. Synthetic data is really the only way that's going to work with, coming back to the DevOps, maybe we can finish up on that. If you look at, your Delphixes and your Actifios, they're great, but they're still just faster versions of production. We're doing some work with Actifio at the moment, and the idea is you spin up the database, and then we just basically just blast in tons of extra data as part of the environment provisioning, with all sorts of different combinations of data that's up to date, with all the different combinations of customers, of transaction types, of currency swaps. All of that stuff just goes in automatically. And that's, again, this idea of thinking of data as modular components. And all I'm saying is, as part of my environment provision, I need these combinations of modules. Go, bang, done. It's not that hard. Coming back to, I always mention Richard Jordan in all the podcasts. Richard Jordan does it at Nationwide. They have a team, very small team, and all they do is every time they provision anything, they just enrich it. And just think of that as just job one. Just enrich it. Instead of finding a bug on sprint 3, you'll probably find it at unit testing on inside sprint 1. And it goes away, and as we know, the further away it gets, the more expensive it is, and that's where the reputation of IT teams falls apart, is because late in the day, something which seems completely obvious breaks the system, So, and a lot of that is just think a bit harder earlier, like everything, blast out all these rich combinations, modularize it, join it up, automate the crap out of it, and then blast it into your development and testing systems, and understand this data gives this result for this reason. And I think if people move to that, that's probably a good note to kind of finish up on in terms of test data, I guess.
Yeah, so I'll add one thing onto that, which is, so I know another area that you've done a lot of work on around process mining, so things like Disco, right? You can understand, I'm an insurance, working for a medical company, I kick off a request for an x-ray, some documents get generated, there's a whole set of cause and effects that are happening there. Using a Disco or something, a process mining tool, you can trace them back to the business transaction, the business process automation, where you've got an RPA tool, which you guys have got, which is incredibly powerful. VIP, and part of that is, I always say, it's always referred to as kind of the just the one tool to rule them all, which people fix all stuff together because there's you have to get data from here, you have to transform it from there, so you need this kind of capability through RPA to do the moving things across and get them in the right format. You talked about CI/CD, so the continuous testing journey. We've got this problem at the moment. Data has a state. So, the guys who are working at MIT and all the volunteers who are doing development, of course, if they change the data's then changed. So this idea of the Netflix, the VTDM database, each person can have their own data source to run tests again, wipe it away, a bit like what Richard Jordan's doing, and then, load that data back in for the next person to be able to use it, is incredibly important. And I think your tools kind of gave you that kind of capability to work with the pipeline. So if you're using Jenkins, you're using Git workflows, there's all that kind of, it's important to think about how you're able to spin all this stuff up, load the data into it, run the tests that you need to, and then blow it away, because that is the importance of being able to prove without having to worry about people having to reserve test data, for instance. So you've got Test Data Automator, which gives that kind of capabilities. You can provision data. I know you've got a really cool tool that literally works in Excel, where you can say, I want 1,000 rows of synthetically generated valid addresses and names. You can just pull it down and it just generates all that. Which most people will say, well, it's just incredible magic, right? And then you've got testmodeler.io, which is this great platform for model-based testing, where you can do exactly what we've talked about today. You can model the scenarios, so you can model those tests, whether it be data, whether it be automations on there. Everything can be done within that model and visualization, which is absolute key. And it hooks into your VIP and your test data generation. So for those people out there, and I know that we've done with Vivek, we've done some webinars recently with James and the rest of the team. What's the best way for them to kind of get started and actually get hands-on with some of this technology and understand just the sheer benefit of what they can get?
Yeah, I think probably the best thing to do is just get in touch with me or James, or just go to Curiosity Software. Let me just look us up on the web, Curiosity Software Ireland, and just book in a little hour discussion, really. We very much, a lot of our work is just chatting, to be honest, just where are you at the moment, where are the pain points. A lot of people will just come to us and what they're talking about is the symptoms. And then you do, it's not hard. You're basically saying, well, actually, the reason for that is actually earlier, and they agree. And then you say, well, how are we going to fix that? And the biggest problem is obviously legacy. I think that's one of your strap lines. So I think legacy, what you need to do then is you need to kind of understand how you can actually get something done whilst still maintaining the legacy world that you live in. And I think that's really the big problem. And people say, oh, I've got a fantastic tool, it does all this cool stuff, but I've got to deal with all the legacy stuff. I'm too busy dealing with the legacy to do anything new. So I think with this time around with Curiosity, we're sort of trying to be a bit more realistic about how you can actually just do these incremental jumps with, within a couple of weeks, you start to create a little bit richer data, and we just kind of add a little bit of extra value, and then you just kind of gradually build more on top of it. So basically just get in touch. An hour chat, we'll just basically chit chat through what you've got, and then you just pick off a few nice things and just get something fixed, really. And then, but I think then it's up to others then within the organization to start evangelizing and think about doing things in a better way. You're a great evangelist. You try and carry people with you, but back in companies it's quite hard, and it's up to the customers and to actually do that internally in there. And we've just got to give them enough material to say, look, is this really working? Is this the way we want to carry on? On a Friday we spend 5 hours doing Git merges and trying to get Jenkins to actually publish something, and is that it? Is that the way we're going to live every week? So I think it's a combination of evangelization and small hops. I think is probably the way to go, and then just get in touch and we just chat it through.
Yeah, and I think that's a great endpoint in the sense of if you go to curiosity.software, it's curiositysoftware.ie actually, Curiosity Software one word.ie, or just go to Test Modeler or just type in Curiosity Software, you will find us. Or go to LinkedIn. And at the bottom, there's the contact you guys. You can schedule, a chat. I know just with what we're doing at the moment, demoing, like you just said, you've got a problem which you're trying to solve. Get the guys to help you go through that problem, show the real benefit of what this can do. Then you can start, being evangelizing within your organization. And an extra thing I'm just going to add in for those people who want to get involved with the COVID project, if you just you can email me at help@coronavirus.fo. That's that'll come straight to me, and I'll send you the details on how you can get signed up onto our Slack channels and help contribute. But, I'm going to say a massive thank you to Huw to taking the time out today. I know you're really busy.
Thanks, mate.
I could highly recommend, it is the best of class product you can get on the market. The team are, the smartest people you'll meet. So reach out to them, email them, and, get involved.
Yeah, great. Great to chat with you again, Jonathan. Carry on, man.
Carry on testing is the thing. So I'll just stop the live broadcast, which is just stopped.